Hello everyone, I'm Gaillard, Professor for Space Policy and Entrepreneurship at ISU, International Space University in Strasbourg. I'm here today with you to present you in the scope of Project ASTRAIOS, which is a project funded by European Union, to which the International Space University is participating, talk about project management. So project management in the scope of the space industry, short courses, few videos, and I hope I will be able to make you learn stuff today and to increase your knowledge and skills in the scope of project management and especially in the field of space and aerospace industries. So project management have several objectives. And that can be summarized into this one sentence. Objective is to coordinate a team course of action to achieve a final objective determined by deliverables and to monitor flux of cost and income to achieve this objective. It seems simple, that's actually big, and that's actually complicated. We will see in the following slides how type of tools, which type of techniques we can use in order to achieve this objective. Project management in the space industry have somehow a dual approach. So there are several approaches on project management. Mainly a technical approach and a financial approach. Usually in the space industry, projects or program are managed by two people, one main project manager and one technical lead. The technical approach to which the technical lead is responsible for is or has for objective to increase the TRL, the technology readiness level, at a company level or on a product level. So it means, technically speaking, develop and enhance the maturity of a product in order to reach a certain milestone and a certain maturity level, which translates into operational objectives. Second, the financial approach. So in parallel with this technical approach, the project manager usually has to secure company funding, maintain cash flow, and ensure that the technical approach of product development or research development is conducted in a proper way, that the project is maintained into certain boundaries. And we will see what these boundaries are. So here's the first illustration of the TRL scale, the technology readiness level scale. The TRL scale has been developed by NASA, and as you can see, they go, I have a pointer somewhere, here it is. They go from a basic level of TRL1, which is really basic principle observed and reported, up to a TRL9, which is an actual system flight proven through successful mission operations. In between, you can see that every step in the ladder corresponds to a certain increase in the technology maturity. And in order to go from TRL1 to TRL9, well, this is a process that takes several years and that goes through several milestones and that also consume some money and also demand investment from material standpoint and from human standpoint as well. Okay, so applied to the space industry, managing a space project which has a technical orientation, and as you've seen, based on the TRL level, with the objective to climb this TRL level, there are several types of projects. There can be purely R&D, so fundamental research and development. It can be product development, so product enhancement, a product which is already researched and developed, but where you want to increase the capabilities. And you can also have non-technical project management, which are events. So in the scope of these videos, we will not talk about the event, and we will focus on projects which have a technical component. So in Europe, in the space industry, the objective is to manage projects and to ensure that these projects are conducted and respect the on time, on cost, and on quality. On time, on cost, and quality is the final objective to ensure smooth project achievements and on a way that usually make a project consortium to operate smoothly. And this on time, on cost, and quality approach is particularly difficult or more demanding when a project is actually run by a consortium of companies, which is quite often the case in Europe. You have several techniques of project management. You have the waterfall approach, you have agile approach, Kanban, Scrum, test fast, fail fast, MBSE, which is model-based system engineering that can be applied to project management. So every project is different. Even every technical project is different. We can talk about a launcher, we can talk about hardware, we can talk about software, we can talk about payload, we can talk about satellite, a lot of stuff. So these different techniques inside each project, the project manager and the project team will have to ensure that these techniques are used properly in order to keep track with this on time, on cost, and on quality. To achieve this on time, on cost, and on quality, or AutoCock, you have milestone. So milestone vary depending on space agencies, vary depending on project, but you have milestone which can be technical review or also which can be payment milestone. And these milestone during the life of a project, which usually can be anywhere between 1 to 3 years, give or take, but 1 to 3 years, you have 2 to 5 or 6 milestone inside this project that will basically help you and help your team to monitor the project and to tick the boxes in order to achieve the project on time, on cost, and quality. So here are an example of project phases, and especially on the execution. When a project is accepted or when a project is funded and a project starts, you have different phases that can go from phase 0 to F. These wording or this wording can vary depending on the space agency or depending on the company, but these correspond to a phase that is mission analysis and identification, where we define the specification and the feasibility, and then the design phase, which is preliminary and critical design review, or detail or critical design review, and then production, so manufacturing, assembly, integration, testing, and then deployment, so in space obviously, and then disposal. Here again, these phases are occurring on several years. From phase 0 to phase F, there are several years, sometimes decades, between these phases. Okay. These phases were particularly true about execution, but a project, it's not only execution. Before executing a project, you may have several years during which the project is maturing and during which the funding authority will basically challenge and evaluate project proposal. So you have a pre-proposal phase, which usually where inside a company or inside a consortium, you will determine a go, no go. So do you decide to go for this project, yes or no? Said differently, what are the consequences for your company, for your university, for your organization of doing this project or not doing this project? For example, if you obtain the project, but if the project fails and is not financed in its entirety, what is the risk associated for your organization? And that's a pretty big question. To proposal phase. So the proposal phase is also in several steps. And the proposal is where, as an organization, you say, okay, we will be able to provide this level of technicality in a determined XYZ scope of years. So for example, we will be able to reach from TRL 3 to TRL 6 within 5 years if we are funded 10 million euros, for example. So this is where you have your technical proposal, you have your financial proposal, and this is okay. You somehow guarantee to the funding organization that this is what your organization is going to deliver. If you are lucky enough to be selected, then start the execution phase, which I just rapidly browsed in the previous slide. And finally, when the execution is done and the disposal of the spacecraft, in this example, complete, well, you have an analysis phase. So this is, you need to get data from your win and your loss. Because with this data, you will be able to create some kind of virtuous circle, and when you will go to a pre-proposal or proposal phase for another project, it will be based on real data and real metrics, and not just guesses or gut feeling.